hope everybody had a chance to enjoy some lunch and imbibe some beer. And now it's the time to sober up and talk about how exciting the suborbital spaceflight program actually is. We've had over a decade of talking about flying, and now in the last couple of years we're actually flying. So with that, I'd like to just start down at the end here. I know we had some introductions, but maybe just starting with Erika to talk about her roles and responsibilities for Blue, and then John and Sirisha, and then we'll get into some presentations, some videos, and then have a kind of discussion up here on the panel. And I'd like the audience to start thinking about the questions that are foremost in their mind about this industry. Foremost in their mind about being a researcher, about flying, about getting other people to fly on the vehicles that we're going to talk about this afternoon. So, Erika?
Hey, y'all. My name is Erika Wagner. I am one of the payload sales directors for Blue Origin. My background's in space life sciences and bioastronautics. I sort of came to the business side of the world by way of the X Prize Foundation. So I've been excited about what's going on in this industry for a long time. I've been at Blue Origin for about 7.5 years, and manage our payload sales process and payload customers on the New Shepard platform, the Blue Moon platform for a lot of our science researchers, and occasionally on New Glenn as well.
And I'm John Kelly, the program manager for flight opportunities. I work for NASA at the Armstrong Flight Research Center, but reside in Tucson, Arizona, which is a cool gig. I've been with the program now for a year, but was actually with the program at the very beginning when L.K. Kabenjan and I, he's at headquarters now, set up the program back in 2011. I was the program manager for, I think it was 4 years when I counted, and left for an IPA job at the Mojave Air and Spaceport, and recently have come back to manage the program again. So looking forward to talking to you about some of what we're doing.
I'm Sirisha Bandla. My official title is Government Affairs and Business Development Manager at Virgin Galactic. I'm a Purdue grad as well, aerospace engineer, so boiler up. I've been at Virgin for 4 years now, so I work on managing the payloads work for Galactic and the payloads that fly on Spaceship Two. But I also work in DC, so we have a small team in DC that engages with our customers like NASA and other government agencies, and also Congress, to work on policies that affect our industry, our vehicles, and also some of the research work that our customers want to do.
Great. So, and I think in the back we have a presentation for John Kelly, and perhaps John, you could walk us through the slides you prepared.
Sure. So what I'd like to do is kind of catch everybody up to date on what Flight Opportunities has been up to, a little bit about who we are, what we do, and where we fit in the NASA ecosystem, a little bit about our history, kind of what we have done to date. And I'll be honest, when I looked at the numbers, I was quite surprised at how much we've done. I've been gone for approximately 5 years, and I came back, and what was started just about 10 years ago now has become quite something, and I'm very proud of that. So we'll talk a little bit about that, and just a little blurb on where we're headed, and maybe a challenge to this community, both the providers, well, the government providers, as well as users. So do I have a clicker, or how's that working?
Oh,
Next slide, or is that me?
I don't know.
Okay.
Let's give that one a shot.
Give that a shot.
It's got a big arrow on it.
Yeah, that seems to work. So Flight Opportunities is a program where we utilize commercial suborbital flight services from the likes of those on stage here and elsewhere. And we use them to give promising technologies an opportunity to fly and get some experience and get them up the technology maturation curve. And so that's kind of like an overall of what we do. And the payload or the technologies come in from various sources. Over time, we've had several calls or solicitations where payloads came in, but we also look for payloads inside of NASA for technology development activities that are happening for payloads either outside NASA or inside that need a flight is where Flight Opportunities comes into play. The graphic you see here on the screen is where NASA is involved with commercial spaceflight providers across the spectrum. And at the very bottom there, you see there's an FO curve. It may be hard to see up on the big screen, maybe not. That's the Flight Opportunities curve, and we utilize supply from rocket-powered suborbital vehicles, from high-altitude stratospheric balloons, as well as parabolic jet aircraft. There's also a rocket-powered vertical takeoff and vertical landing vehicle we have used quite a bit as well in the past. So that's kind of where we fit in, and we are exclusively focused on the suborbital domain. And here is a view from that domain, from VSS Unity back in February. This is a flight or a shot from that flight. And not only were there 3 Virgin crew on board, but there were also 4 NASA payloads, which we're quite proud of. And this is the kind of environment that payloads that come through our program get to experience when they fly with the likes of Virgin and Blue and others. And this is the chart that really made me stop and think about what we've been up to. Since the inception, again, 2011, we have had 184 independent or individual flights that the program has funded. And on board those flights, we have flown technologies and we've given opportunities 651 times to technologies, to payloads to fly. So one payload, one flight is part of the 651. And so there's been quite a bit of activity. If you just spread that over 10 years, it's 65 technologies that get to fly every year. And that's quite a lot. We currently have 68 active technologies or flight programs in our library. Now, some of those are at various stages. Some are still waiting for a ride. Some have flown and are waiting for another ride. And some have actually finished their flight activity, just a handful, and are waiting to be closed out. But just last week, we also added 25 more technologies through a thing we call the Ready Tech Flights solicitation. And so that announcement came out on the 3rd. So 68 plus 25, 90-ish active flight projects, which is a lot. Oh, actually, can I go back on this one? There's only a forward button. Can we go back one?
There's no going back. We're just always moving forward.
No, I want to go back. Oh, here we go. Yeah, so I meant to mention, speaking of the perspective, this is actually the money shot from a flight we did here at Spaceport America. That's looking over the edge of the Adept TPS payload. So we flew up to, I think it was 108 kilometers, and we released this TPS payload. It's kind of like an upside-down umbrella that allows payloads to re-enter an atmosphere, and these tines you see, or these umbrella tines, actually articulate, and you can steer the recovery of that vehicle to a certain spot, wherever you happen to be landing. So that's a test we did here at Spaceport America. Okay, so technologies selected to date. I told you we had so many flights and lots of opportunities, and that has been comprised of about 250 different technologies within our what we call pipeline. You can see on the left there where the PIs come from. They're broken out by percentage, and then the types of platforms that are being requested by those principal investigators.
So what are the abbreviations in your SP, SRLV?
Yeah, so on the platform type, if you look in between, there's a couple of small wedges. Mm-hmm. That's where a PI has asked for a flight on 2 different types of platforms for the same technology. So some of them will fly on a reusable rocket as well as a balloon, for instance. Mm-hmm. And those little wedges represent the percentage.
Right, so our suborbital vehicles are where on that plot, on the platform type requested?
Where are they?
Yeah.
The SRLV?
SRLV, okay,
yeah.
Great.
And that's kind of a loose designation for the rocket-powered vehicles we use. And included in that would be like the vertical takeoff and vertical landing rocket. Okay? And then fast forward to last week when we announced 25 new payloads to the tune of about $10 million in total value, and with 2 topics. And these topics align with the stated themes of our NASA Space Technology Mission Directorate. That is exploration and the commercialization of space. So 2 topics. Topic 1 was a value of up to $500,000 per award. Topic 2, up to $300,000. And the top one is kind of the highest priority, sustainable lunar exploration and economic activity in cislunar space. That is the space between here and the moon and around the moon. And then topic 2 is essentially commercialization of LEO, and that would include commercialization of suborbital space as well.
So on those awards, part of that award is actually going directly to the flight provider.
It is.
And then another part of that is retained by the PI for the development of their payload or.
It is, and that, Sean, is a
integration.
change. So last year in the 2018 solicitation, we offered up to $275,000. And if you recall, I just said 300 and 500. But up to 250,000 in last year's call could go to acquiring a flight, and then 25,000, which is not a lot of money for basically getting to the flight. No money in there for payload development, which is a big hole in that, drawing in good technology. So this year in the 2019 call, we opened it up to where that $300,000 or $500,000 award could be used for anything, really. But it had to include acquisition of at least one commercial suborbital flight.
And so those proposals are written by a PI in collaboration with the vehicle provider to provide the cost, and then that whole package is submitted to the NASA Flight Opportunities Program.
That is correct.
Right.
Yeah. And there's a link there at the bottom. If you get a copy of these, you can go see that award announcement. And you can also see there where the PIs came from, the awardees, and what types of platforms they were requesting. So this is a hard chart for me because there's a lot of really cool things that happened while I wasn't here, and so I had to come up to speed on some of this. So I'm not going to really get into the details in the interest of time, but the program is successful, and the utilization of these commercial suborbital platforms is successful when those technologies actually find their way into a NASA mission or into a higher order test. And so there's a list there of the different types of things that have been or will be infused in future tests or future missions. Just wanted to point out there at the top, the lander vision system. This is the JPL produced, developed system that will do what they call TRN or terrain relative navigation for Mars 2020. So it's actually infused onto that mission and will fly there when that rover goes to Mars. We did a lot of testing on some of the technologies that went into lander vision system on various platforms in our library. And all good. And like I say, if I knew more about those other ones, I'd talk about them. This is my get off the stage chart. I want to kind of leave us with a challenge. And this is a challenge we have made, Chris Baker, the program executive, and I have made to our team as well. When we say we facilitate rapid flight testing, what does that mean? Well, I can tell you what it means in terms of how we execute right now. Rapid right now is the solicitation takes about 1 year. And then if you add on top of that 18 to 24 months for a PI to build a payload and go execute a flight with one of the providers, you're talking about a 3-year cycle. So is that rapid? I don't know. We think we could be rapider. And so we have challenged our team, at least for right now on the solicitation side, to see if we can squeeze that solicitation down from 1 year to maybe, 6 months. So we can squeeze 6 months out of the system that way. And perhaps there's a way to incentivize the PIs, the proposing PIs, to, hey, if you can do it in this amount of time, perhaps there's an incentive there to get them to fly a little quicker. If you think about NASA wanting to get to the moon, or the US wanting to get to the moon in 2024, and you have a 3-year proposal cycle for technologies that are aimed at the moon, you get 1 1/3. You don't get very many shots through that process to get technologies matured for that mission. So, Sean, that's all I had to offer.
Thank you, John. And I'd really like to applaud NASA for embracing the opportunities within the Flight Opportunities Program, the new vehicles, and then invite Erika to talk about the Blue Origin program, and if we could cue up Blue's video.
That's right.
And Erika, if you'd like to provide an introduction.
Yeah, thank you. So we're going to watch a quick video that's some of our previous PIs and researchers that have been flying with us, telling a little bit about their experience of coming out to West Texas and why this works so well for them.
I think that's going to be great for the field. Yeah,
Can we get the audio up a little and restart?
For me, the guaranteed return of payload has just been critical. It's allowed me to fly prototypes in very early designs. Basically, it is extending the laboratory and testing environment up to space.
It's really remarkable that we can get up into space and we can do it so much cheaper, so much quicker, and repeatable compared to trying to go to space station.
This is the L-4 VPF load.
Space is the perfect vehicle for looking at problems that can't be solved in one discipline. So as these price points come down, you start to have people like me put a payload into space, and you can have creative solutions to long-standing problems.
It's a revolution in how we're thinking about space travel, so hopefully we can get a lot more interesting science out.
So I think the story that our customers have been telling us, we're coming up on our 12th test flight, our 9th payload flight. We've had dozens and dozens of payloads on board from small institutions, large universities, research labs, government agencies, K-12 organizations and schools. And what we keep hearing over and over again is that this is a fundamental change in how we think about getting something from an idea into space. And so I wanted to just highlight a few of those differences that might make a difference in the organizations you work for. Number one is, as John mentioned, we're moving faster. So you can take an idea from concept to flight in about 6 months with Blue. We can stretch those out too if you need more time for tech development. But that ability to move from an idea to flight in months to weeks or in weeks to months rather than months to years is a big change in the industry. The second thing that we've done and that we've seen a big difference on is we've tried to make it easier for folks that are new to the space world to develop their space hardware. And we've done that by providing structure. We provide payload lockers and also flight computers that have already been flight qualified. So this means if you have an idea and a little bit of basic lab skills, you can take that idea and move it into flight. The environments of the vehicle also make that simpler. So being in a vehicle that's designed to fly humans like ours are means that you're going to see loads on your hardware that are consistent with the loads that my mother and I would want to experience when we're flying. So that means that we're going to see gentler ascent loads. Sounding rockets are on the order of 20 G. We're on the order of 2.8 G on ascent. You're going to see standard temperature and pressure inside that capsule, so that means anything that's working on your benchtop environments is likely to be able to work in those environments. And you're going to see the ability to get that hardware right back. It's going to come straight back to recovery and straight back into your hands. So if you want to take that hardware and fly it again, or use it as a protocol unit for your CubeSat, or take it and use it for other purposes in your lab, that hardware is back in your hands. I think the third thing that's really changed is just the price point, and also the way the procurement happens in this space world. So Sean was mentioning the ready tech flight solicitations. You'll come to us and ask for a commercial bid for your flight, and we'll hand you a bid letter that says, here's what the price is and the timing that we expect. And you can take that and put it into any grant that you want to. The Ready Tech Flights are the most obvious one. That's the program that's sort of set up for this. But we've had customers that are putting this into SBIR grants, not just NASA, but DoD and other agencies. We've had researchers that have gotten funding from NSF and NIH. We have researchers that are crowdfunding and schools that are doing bake sales and car washes to get into flight. On the small end of our payloads, our student payloads, those are about a pound of payload at $8,000. And I don't know those of you who have kids in the system, but that's literally less than the cost of new football uniforms for a football team. So for a school that can have an athletic program, they can now have a space program. And that's a game changer. It's a game changer in how we get a workforce that's ready to go and do the next generation of things. And it's a game changer in terms of who can access space. So it's not just the big top tier 1 universities, but we have second graders in rural Indiana that are flying payloads now, and that's really exciting. That's cool. A couple of things that are coming down the pipeline for us in terms of upgrades to our payload system. We've been, as I said, flying these payloads in the crew capsule for a couple of years now. There's been an incredible demand for payloads flying outside the capsule. And so we're in the middle of architecting an interface on the booster side. So if you have a payload that needs to be exposed to the spaceflight environments because you need that technology readiness level or that access to hard vacuum, that's now an option. We have a flight that we've started talking about that would take the capsule and spin it like a giant centrifuge. About 10 RPMs gives us lunar gravity inside the capsule. And when you're starting to talk about technology readiness level for a lunar system, whether that's phase change materials or heat exchangers or flow boiling or combustion and fire safety, a lot of these questions are ones that you cannot answer in 20 seconds on a parabolic flight. You need a little bit longer. So we can get about 2 minutes of partial G time on the vehicle, we think, and we're looking at doing one of those flights coming up here. And then the last thing I wanted to sort of mention was this connection that's coming to low Earth orbit, and as Sean has queued up for us, space is a very connected place. There are certain things that you really only need a few minutes, and suborbital is exactly the right place to be. There are some things, though, that really do need to go to space station or cislunar or the lunar surface. And for those, we see ourselves as a really interesting stepping stone. So increasingly, we're seeing organizations coming to us and saying, I need some risk reduction. The hit rate on CubeSats is less than 50% make it through their mission maturity. Can we do anything to improve that? The rate of technology failures or problems or procedure failures and problems on ISS is quite high. Can we reduce that so we have more yield for the big investments we're going to make down the line? So that risk reduction strategy is a really interesting one. The preliminary data strategy for those who are looking for investments. I can show my investors in the next 6 months that I have something that's been to space. That's real progress and really very tangible. And then the last thing is that the places that ISS is resource constrained, we have a little bit more flexibility. So we can do hundreds of student experiments per year. We can take an experiment that needs to scale up in a way that may be constrained on other platforms. And we can take the opportunity to get you there, not just with astronaut crew time from NASA, but moving into that era of investigator-tended experiments as well. So just as a show of hands, how many folks out there would tend their own experiment if given the chance? Hands-on in space. Okay, I'm in the right room. I think we're good.
Yeah, for sure.
I'll leave it at that. Sirisha, you're next.
Cool. I'll talk before we play our video, so hold off on the video.
Yeah. Okay.
So just in general, if you did not hear Jim, Tara, Beth, Mike, and George speak today, I'll go through a quick overview of what Galactic is doing. So we have a hybrid vehicle. That is our platform for access to space. It's a carrier aircraft with a spacecraft that can take up to 6 people and payload to space and back. I could go through the list that Erika just went through, but I actually want to go through some real world examples of how researchers have used our platform and how we plan to use it in the future. So right now we're, as Mike had mentioned, we're moving to New Mexico. So our commercial flights for research will happen out of New Mexico. But our last 2 flights to space have been out of Mojave. So we've had researchers there prep their payloads and fly their payloads there. And one of the payloads that flew on both flights actually was a payload that has been waiting to fly since the 90s. It got kicked off of shuttle, and it finally made it to space in December of last year and February this year. They've been waiting a long time, and we were able to do it. And I think it's one of the benefits of these types of vehicles where there isn't as strict of a form factor requirement. We can look at different ideas that researchers are bringing and find a way to fly it. And I think that kind of creativity is going to really show down the line in terms of the pipeline of payloads and research that we're going to be able to fly in the future. A second example that I think is really fascinating to me in terms of flying payloads. So on the February flight, we had a researcher that was holding his payload and looking at spaceship in our hangar. Well, his payload was on a cart. It seemed more glamorous for him holding his payload, but it was actually on a cart. That's the safe way to transport payloads. So I walk up to the researcher and I'm just like, do you need anything? And he's like, it's interesting. I gave you guys my payload yesterday. It flew into space this morning, and I have my payload back, and I'm about to look at the data. This is really a new era for commercial space flight. This is really a new era for payload flight. So I think that I knew we were doing this, but for him to actually take it in and just repeat it to me made it real. And we're really excited to have this high cadence and frequent space flights moving forward. And I think that's going to allow for a lot of things that Erika mentioned, allow researchers to fly payloads often, be able to tweak, look at the data, and fly again. And maybe that will lead to lowering the risk for flights to more long-term destinations in LEO, beyond LEO, or maybe that's enough. Maybe frequent flights in suborbital space will be that person's research. And that could be anywhere from a commercial company to students. And I think that's another really exciting portion of what we're doing, is that a student can actually design, build, and fly a payload in their time at a university. Typically for ISS and other methods of going to space, it's very hard for a student to do that within the years that they're at university. So this is really another exciting way for us to be able to provide different programs. So with that, I think
You have your video? Do you want to show
play
your
our
video?
video,
Great.
which is not unsimilar to Blue's. You might even see the same face.
I'm here today working on a payload that's going to be flying on Virgin Galactic Spaceship 2. The payload is designed to study planet formation and to assist in developing safe operational procedures on small airless bodies.
We want to characterize the flight environment and see its suitability for future experimentation, research, and technology demonstration. We go to space a lot more frequently and a lot more inexpensively. It's going to then enable us to push our technologies out. And in particular, too, I'm excited about the prospect of researchers and engineers flying their payloads, extending the laboratory environment up to space.
Great. So I think one of the things we see here is kind of a direct hands-on environment. What do you see is some of the payload integration hurdles that researchers have, and how have we been addressing that? Do we have like third-party providers that are accessible to help payload developers? How do you see us growing this market? And maybe just start with Erika and Sirisha on this.
Yeah, it's an interesting question because many of the users that are coming to us in the early days had a lot of experience with spaceflight. They had designed space shuttle or space station experiments. They had a lot of that intangible experience. They had run through these test procedures before. They knew how to fill out the paperwork, all that kind of stuff. As we've expanded the access to space, we're getting a lot more folks who are new to developing spaceflight hardware. And that's been a really good lesson for us, and it's really pushed us to streamline our paperwork and to improve the cycle time through. One of the things you see on both space station and in the suborbital domain is some folks are going to what they call implementation partners. So implementation partners are organizations that do have that experience building spaceflight hardware. So maybe your small business has never built a space experiment before and doesn't really care to develop that core competency. You can go to an organization like TechShot or Space Tango or NanoRacks that has that experience building that spaceflight hardware and collaborate with them. And I think this is one of the things that the READY program has really foreseen, is to allow for those kinds of collaborations between academics and private industry.
It's wide open, yeah. Yep.
Yeah, and also even in the ready side, as we're going to get more experienced people, there's still a lack of experience in terms of how to even propose. So I think that's an area that we could, definitely use some collaboration, and there's definitely groups, and Flight Opportunities has been great about this, about using workshops to help people even look at the proposal process of getting funding for flights. And I think in the beginning, when we had a lot of proposals from experienced researchers, that wasn't that much of an issue. But as Erika said, as we've increased the amount of people who want to fly their payloads and the areas that they're looking at to fly payloads, which is different, which is areas that aren't typically traditionally areas that you'd see space-based research, you're getting a lot more new people that haven't gone through the process. So of course, as we start flying, you'll get those experienced people out there, but before, it's good to keep the community strong with organizations like SARG, which, excuse me, Sean, you're very familiar with. It's the Suborbital Applications Researchers Group. That's part of the Commercial Spaceflight Federation. They're a group that hosts workshops, that hosts conferences that allow people that are new to the industry and that want to fly come and gain that knowledge from people that have done it before. Also, from a Virgin Galactic side, we're trying to keep our processes pretty simple, quote unquote. We aren't trying to do anything that's so complicated that requires a lot of paperwork, that requires you to know how a rocket works to fly a payload. So we're trying to keep it as much as of a plug-and-play process as we can. Of course, there's experienced researchers that want to fly payloads that are outside of the box, and with that, we can always go one step further and work with them one-on-one. So. there's different methods to fly.
If I can just speak to that dichotomy, right? We have folks that are doing literally world-class boundary-pushing science and engineering, and then we have second graders that are getting hands-on with experiments. And the fact that both of those kinds of things can fly on these vehicles is really interesting. Yeah. For those of you who are out there that may have experience developing spaceflight hardware, find a school to work with. There's a great group we flew, a DCS Montessori school out of Denver area. They took a K through 8 school, and they had all the kids involved in some aspect of their flight working with a local engineer that could help them with those boundary setting. So the 8th graders were the program managers, the 7th graders did the 3D printing, the 6th graders programmed the Arduino, the 5th graders did the science, the 4th and 3rd graders worked with the little kids to do art projects that went inside the Nano Lab. So these things are really possible if they have someone who can say, hey, here's how we can stay within that box, and here's how we can do it safely.
Yeah. So as a program, it's hard to watch a payload fail, but they do fail, and we're putting pretty good money into that activity, and so this maturity level of PIs is something that I think about a lot. No, we haven't arrived at any kind of like what we're going to do about it, but there's enough payloads that fail that it's not an insignificant amount of money. And so we are starting to think about, and I hope we together can think about ways to bring the PIs and these new researchers up the maturity curve to bring a viable payload to bear. I'm sure you guys will fly a box of rocks, In fact, you have. You have flown a box of rocks. But I mean like a box of rocks. But I want that box of rocks to work. And so
I believe that's a valuable experiment, too.
I will say the actual box of rocks experiment was fantastic.
So you could fly a bowling ball. How about that?
Well, people that want to study collisions in a microgravity, that's what they're doing. They're flying a box of rocks. But one of the questions that the audience has, and certainly in my mind, is we have 2 vehicles which are geared towards human spaceflight. Right? We've got these researchers that you see in the lab that are developing their payloads, that pretty much automated payloads. So what's the balance, what's the trade-off between human-tended payloads and automated payloads, the trade-off between cost and risk, and will we see, I think we heard an announcement about Italy and Virgin Galactic, but what is the role of humans in these experimental programs, and how does it see it from the Virgin perspective, from Blue, and from NASA?
Yeah, I'll go first. So Virgin Galactic announced last week that we signed a contract with the Italian Air Force for an entire flight, a research flight, with payloads and 3 researchers. So we're definitely moving into the human-tended flight realm. So I think there's 3 buckets. So there's bucket 1, which is completely autonomous payloads. They have to work on their own, they have to run on their own power. So that's bucket 1. It does include a sense of complexity in terms of the payload. If anything goes wrong, it either has to correct itself or shut down, which could mean you have to refly. So it typically makes that payload heavier and a little bit more complex in terms of the systems. There's the second bucket, which is payloads that require some sort of human tending, but it could be done by a provider's employee. So a VG employee is in the cabin, presses a button. So that could help for some payloads that just have a tough time triggering at the right moment. So if it's just as simple as pushing a button, flipping a switch, there's an opportunity for VG employees to tend to those payloads. That, again, reduces the complexity, and it can also reduce some of the errors for a payload to not fire at the right time. It could also call for a reflight, which could be expensive for the researcher. So that could reduce complexity, and it can be done pretty easily by Galactic employees. And then there's a third bucket, which is the human-tended bucket, where the human-tended with the actual researcher. And that is payloads where the researcher is going to be flying with their own payload, interacting, being able to do real-time observations because they know what they're looking for, and they've designed the experiment in a certain way that a Galactic employee just doesn't have the background to be able to do the tasks or be able to observe the right things. So that is a whole new area, which I think is not novel for a lot of researchers in different fields, but is novel for space because not a lot of people have the ability to fly to space with their payload. Typically, you hand it off to an astronaut for NASA or another government agency. And this will really reduce the complexity of the payload because the researcher who's intimate in the way it works and knows exactly what's going to happen is there with it and can make real-time changes and observations, which I think is a whole new area which is going to provide a lot of creativity and a drive for a different type of research. It also allows for a lot of physical and life science research that hasn't really been done before. So we're really looking forward to being able to do that as well.
Maybe area 3.5 is the sort of on the human. There's a lot of opportunities as we open up these doors to more folks who are flying. And as Tara and Smith and others were talking about this morning, that we're going to see a whole new kind of astronaut that's in our vehicles. And we're going to be able to gather data on people who are of different ages and different health statuses and different issues that they're taking with them into flight. That offers a really wide opportunity for data collection. And so I think that one's sort of maybe 3.5 or 4. Yeah. John?
Yeah.
So NASA doesn't currently have a program to fly PIs, NASA PIs, with their technologies, with their payloads on commercial suborbital vehicles. But we are considering a policy to allow grantees under our Ready Tech Flights Awards to fly with their payloads. And that's if, in doing so, it enhances greatly that activity or actually enables it, makes their test plan viable. And with the addition that the PIs, the Ready Awardees PI institution actually approves of that activity. It's an institution committing their maybe employee or student to this activity. So we always allow for the commercial providers to provide a crew member to do that interaction, which I think is a great solution. Yeah.
So a question that comes up is like the long-term position for these suborbital flights. 600 tickets sold for Virgin. That's 100 plus flights that are for space tourism. Blue going from the New Shepard to the New Glenn vehicle. Is suborbital research on these vehicles here to stay? Or is this something that we just take advantage of it while we can? How's this going to play out in the years ahead from Sirisha and...
Well, I think that's yes is the short answer. I definitely think it's here to stay. We do have 600 people signed up, over 600 people signed up to fly, but we place a very high importance on research and science applications as well. We've got Unity, which is our spaceship that's in flight test right now, but we've got 2 others that are being manufactured as we speak. And with those 3 spaceships and more in the future, we're going to see a mix of both human spaceflight for tourism, but also payload flights and human-tended flights. So I think it's going to be a mix of all 3, and I think it's going to be something that is ongoing and reoccurring because there is a lot of iteration that research can do. There's a lot of iteration on payloads that researchers can do, but also as we go through and get to commercial operations, I think actually flying payloads and looking at what we can do on a frequent basis, which is something that we don't have access to right now. Some of those lines and some of those opportunities that will come, I feel like I can't even predict them. But we'll see different lines come out of those payloads, and we'll see where it goes. It can either go, onward to orbit, or maybe it'll stay within a suborbital spaceflight regime.
Yeah, when Blue Origin started our payloads program, we thought it was a good idea. We thought it was an interesting idea. We now have market demand, and if there's market demand, we will be flying that. And I think that's a really good thing. We've dedicated one of our crew capsules to flying payload missions, and that gives us a system that's optimized and available to do those when we need to, which is great. The other thing that we're finding is that we can use this vehicle, and research for our own, for Blue Origin's own purposes has been useful. We've flown a number of tech development payloads for our own systems, maturing from New Shepard to New Glenn. We recently got some funding from the NASA Tipping Point program to develop, in conjunction with NASA, some terrain relative navigation and sensing and landing systems for our Blue Moon system, so our lunar lander. And we're testing that on New Shepard. Turns out that going from 70 kilometers down to the lunar surface surface from a low lunar orbit, or 70 to 100 kilometers on New Shepard down to the Earth's surface, gives a really common test environment. So we have a lot of utility out of this system ourselves, which gives us even more incentive to keep it flying.
And from a NASA standpoint, we are very opportunistic. So if there's a commercial spaceflight provider, whether it's suborbital or orbital, we want to use that to accomplish our mission requirements. So we'll use whatever's available. And right now we're enjoying the utilization of these suborbital vehicles.
And one thing I forgot to mention is we do have NASA and is a great partner, but there's a lot of countries that don't have a space program, and vehicles like ours are a way for that company or that country to be able to access space without actually spending the money or the expertise of developing their own vehicle. And it's an easy way for countries that don't have a space program to be able to fly things into space and actually maybe even have a space program without having a vehicle. So I think it's really exciting to see not only some of the US companies and universities fly payloads, but also other countries, those with space programs and those especially without.
Right. We've got a number of questions here. The countdown timer is going off, so I guess I would invite our audience members to come up and meet with Erika and Sirisha individually about their program. And
so we've got questions from the floor.
Oh, okay.
So we've got a couple minutes for questions from the floor.
Oh, we do.
So that
right.
countdown timer was for you to stop.
Oh,
so we
okay.
could have time for the questions from the floor, if that's okay.
Yep.
Okay,
Great.
So let me just say, first of all, this is the suborbital panel, and I've got a number of questions here that perhaps confuse a little bit the difference between suborbital and orbital. For example, there's a question about how will Blue Origin and Virgin Galactic protect against orbital debris, and that is not
That's actually way
applicable to
easier in
suborbital.
suborbital.
Yeah, so there's another question, I think, about are Blue Origin and Virgin Galactic going to have orbital spaceflight programs in the future? And the answer to that is yes. George Whiteside answered that question at his presentation for Blue earlier, and I'm sorry, for Virgin. And Blue Origin has got the New Glenn program, which will be orbital. So I just want to take those off the list real quick because, again, we're concentrating on suborbital here. So the question that the audience wanted to ask, John, is there a way to streamline the solicitation and proposal applications, especially for smaller universities?
The answer is yes. What the right answer is, we don't really know yet. Right now the solicitation cycle is about a year, like I mentioned earlier, and there's probably ways to reduce that time. We are very careful on how we solicit for technologies, how we receive proposals, and how we review them, and how we recommend them, and how we actually select them. It's a very tedious process, but I know that there are some savings in there that we could make if we just looked at it a little more closely. Part of it is we live up to our expectations, and if we say that the proposal cycle is a year, well, guess how long it's going to take? It's going to take a year. If we say you can propose up to a 24-month program, well, guess how long the proposals are going to be? 24 months, and about $500,000. And so there are ways we can streamline it. And in terms of fitting it into like an educational cycle, like a semester maybe, that's aggressive, but I think it's possible if we really take a hard look at it.
And something to consider also, maybe, John, while you're here.
Sure.
In terms of like flying frequently, and there's different vehicles, and there's parabolic, there's different suborbital vehicles, but looking at campaigns for the future for a researcher to maybe say that I do need 2 flights, or I need one zero gravity or parabolic flight, and I need 1 suborbital flight in the future might also be an interesting way to streamline research and proposals.
No, that's a good point. And so that's already available. If a proposer wants to propose, I want to fly 3 times on Blue or Virgin, or on a balloon and a rocket and a landing vehicle, they can do that. So a lot of it has to do with how much money they have to do that work with. And so there are dollar limits, for those activities. But there are instances where the program can fund and extend grants, for instance, to add flights if we think that technology is going somewhere.
And I think the HEOMD, ROSBio call, the SMD, ROSA's call, the tipping point call through STMD, HRP's HERO call. There's all these other solicitations that if you look at them, they have a specific paragraph in there about how to apply for suborbital opportunities within those grants as well.
Small spacecraft technology, if you didn't mention that, it's in there.
Yeah.
We are also trying to make connections with SBIR as well and game changing. So there are technologies that come up through the NASA program space that need a flight. And so we're trying to make those connections.
So whichever solicitation you're comfortable with and familiar with may be the right option.
Yeah.
Okay, question that we have here, will any of you consider flying research animal rodent experiments?
Yes.
Yeah.
Absolutely. If it's able to get through
payload, of course.
if it's able to get through the safety procedures, is covered by the appropriate animal care and use committee reviews and the appropriate IRBs, that's absolutely something we're open to.
And we are opportunistic. If they provide that and we need that as a requirement, we'll use it.
So what sort of safety requirements are placed on these suborbital payloads?
Yeah, so online, before I just list through a bunch of them, so Virgin Galactic has a payload user's guide. The payload user's guide goes through exactly what you see on a flight, but also goes through, here are the structural requirements, the electrical, if you're using fluids, here are the containment requirements. So we do have a user's guide, I'm sure Blue does as well, that you can look and see everything that you need to be able to comply with to fly on our vehicle.
And we accept that. We also accept the FAA's regulation regime that covers these types of vehicles. We defer to that. So NASA does not impose any new regulations or requirements on top of the activity that the FAA already approves, which is great for us. It's a lot less work, actually.
And for us.
Yeah, exactly.
So both suborbital flights are relatively limited in microgravity time. Are there any plans, and I'm summarizing a couple of different questions here, are there any plans to extend that that microgravity time for either vehicle?
Yeah, so what we get on our flights right now is about 3 minutes of microgravity, which is an order of magnitude longer than a parabolic flight, about 2 orders of magnitude cleaner in terms of G-jitter and acceleration environments. Our vehicle is really optimized to that Kármán line limit, so we're going up to about 100 to 107 kilometers for apogee and then coming back down. We don't plan on going any higher with this vehicle, so that's what we're really optimizing for.
Yeah, and we're getting about the same, about 3 minutes. So that's really what we're aiming for. But also in terms of reduced gravity, there's a lot of interest in that quality and that duration just because, as Erika mentioned, it's a lot longer than drop towers and parabolic flights, and it's a lot cleaner in terms of the G-jitter that you would see. But also we've seen a lot of interest in also the transitory side of the profile, so from high G to low G, and then maybe down to high G again. So we've seen interest not only in the reduced gravity, but also the high G portions of our flight as well. So there's a lot of applications that we're seeing in terms of the research being done.
Good.
There is one question about startups on that, and we have Made in Space is the next talk in this series. I think they did a great job of gaining their microgravity intuition through their zero-G flights. For startups working with either Blue or Virgin, is it cash or equity? What can startups offer?
We do it on a purely commercial basis, but we love working with startups because we see that as the real pipeline that's needed to get this industry up and going. We've had a number of small businesses fly with us, and I love that we've gotten to that point where it's not just the big primes that get to go to space now. Anyone that has the ability to write a grant or talk to their angel investors can actually raise enough capital to take something to space.
Yeah, same. So we're basically purely commercial, but we've seen companies come to us with different types of instruments that we'd actually possibly consider using on our own spaceships. So it's not only just hey, we're going to fly and make that a relationship, but we have been interacting with startups and even university students that are doing very interesting things that we'd like to utilize on our vehicles in the future. So there's a lot of opportunities.
Earlier, one of you noted that payload integration was less than 6 months. Payload licensing via the FAA and international rules is longer. Is that because the difference is because you're suborbital, or can you reconcile the time limit to get a payload license?
So we have a payload license that covers all common kinds of payloads that fly on our vehicle. So that part is already taken care of for our customers, except in the most extreme fringe cases. So that's already been worked through for you, and that's why you get to take advantage of the shorter timelines.
Yep.
Okay. What do you think of the idea of a regional center of excellence for microgravity research? Would the companies be interested in contributing to that?
Well, I think it's a great idea. I was going to bring it up earlier when we were talking about how to consolidate different areas of expertise. There isn't a center of excellence for microgravity, and I think this area, which we've got Blue's test site not too far away, we're right here. I think it's an area that's ripe to be able to do that. But I think it's a really good idea to have one center that is the knowledge base for not only suborbital, but different platforms for reduced gravity research. And I think that not only will help educate future researchers that want to get into the field, but will be able to help transit different technologies through different platforms that we've been talking about and reducing TRL to go to orbit. So I think it shouldn't just be a suborbital center of excellence. It should be a reduced gravity or microgravity center of excellence that can hold this knowledge and go through years and generations of researchers and universities. So
there's a challenge for New Mexico State right there.
Yeah.
I was going to wink.
It was, yeah.
And for those who are interested in the field and have never been, the American Society for Gravitational and Space Research is the big sort of academic home for that kind of work. Their meeting is next month in Denver, so not so far away and not too soon.
Okay. Erika, I'm sorry, Sirisha, how many White Knight Spaceship Twos does Virgin Galactic anticipate building?
We'll need or have?
How many do you anticipate building?
How many are in
Oh,
the
so right
queue?
now we have one White Knight, and we have one Spaceship Unity, and we have two that are being built right now. We'll see where the market goes. With the 3 spaceships, I think we are planning on going to commercial ops for both humans and research. When we see the market demand with the 3 spaceships, we'll make the decision on how many more we'll need in the fleet and how many White Knights we'll need.
STEM payloads are very cool, but what is the paying profitable business driver? What is the killer use for your systems?
Killer use.
The killer use is ultimately someone who flies on our rockets and makes money. Right? I think that's where we've all got to get to when whether we're talking about LEO commercialization or cislunar commercialization or suborbital commercialization. As long as this is something where it is only money in and ideas out, we can't grow as fast as we will when there is money in and profit out. So I think that's what we're looking for is those kinds of things where someone is actually deriving insights that drive new products or making products themselves on these flights. It's been a thorny nut to crack across the industry, but that's where we'd ultimately love to get.
Yeah, in terms of STEM education, I mean, I know this is going to be a super corny and cliche probably answer, but some of the reason why we do some of the work in STEM education is really to build a workforce to continue, the next generation of entrepreneurs, engineers that our society needs and that our industry needs to actually continue being an industry. So when we think about STEM, I know there is the money factor, but I think the important thing is to really focus on the students and building that knowledge base so that we as a society can thrive.
Okay. Are either of you considering how they might implement and provide security for classified payloads?
Yeah, that's something we're open to. We have a couple of different ways we can work through that process, and I'd be happy to take that question offline.
Yeah, absolutely. So we're working on being able to fly those payloads as well. Our sister company, actually, Virgin Orbit, has a entity called Vox that is able to fly and work with classified payloads, so we have that ability as well.
Okay. What's the biggest challenge to support successful payload availability to support timing integration for those that want to launch on a schedule? What's the biggest challenge?
That wants to launch.
What is the biggest challenge supporting integration for those that want to launch on a schedule, payloads?
For us, it's mostly the biggest challenge has been funding. Just that timeline of going from an idea to a grant to a selected grant to a funded grant to a contracted funded grant to a payload, it's a long one. We'd love to shorten that up. I know John's sensitive to that.
Yeah, I am, yeah.
And that was the last slide. I mean, I think, I think we just need to think about the problem a little bit.
Yeah.
And I don't think the solution's that far off.
And it's all of us, it's not just NASA. Yeah.
Well, I think there's one question which is addresses what is the process for applying to the Flight Opportunities Program? What are the things that Flight Opportunities is looking for in a successful proposal? Maybe John, you can talk to those people that have been successful.
So I would just say read the solicitation, because we say right in there what the evaluation criterion are. I can't prattle them off, Sean. I'm not that familiar with it, but I do know this, because I have seen quite a few proposals. If you don't write a good one, you probably won't get selected. It's pretty simple, frankly. Follow the directions, pay attention to the evaluation criteria, because yes, we do grade against those, and write a good proposal. If you're gonna, as an organization, as a company, or as an academic organization or other, if you're gonna spend the B&P money to write a proposal, write a good one. That's what I would say. I'm a little surprised, frankly, at how many bad ones I see. And it's with a little extra effort, you might be successful if you are one of those bad proposal writers to be successful and fly with us. But read the solicitation.
I'd also encourage you to talk to the flight providers early, make sure that we can accommodate the needs that you have and that you know what it takes to fly with us. That's a process we're happy to start even now for the solicitation coming out in the first of the year. It takes a couple of weeks to get through that cycle, so start talking early and often.
Yep. But I think one of those issues is the relevancy of the technology to the NASA roadmap.
Sure.
That NASA is going to fund things that make sense for NASA missions. And so if it's dual use with its commercial application and its NASA application, that's still something that's attractive to the Flight Opportunities Program.
It is, and we allow for that. However, if it's a commercial activity, so a commercial company proposes, we do have a cost-sharing requirement for that. But there are instances where you can be a commercial entity and receive a commercial grant with no cost sharing, but it depends on how it will ultimately be marketed. And again, that's all in the solicitation, so take a look at that.
John, I don't think people were too thrilled with your discussion. Can you give examples of bad versus good proposals?
No, I can't.
No. Okay, do the payloads have to be FAA certified? FAA certification for the payload?
No, so I think Erika mentioned there's a class of payloads that FAA has already approved, and if you fit into that class, you're able to fly on both of our vehicles.
Okay. Virgin Galactic is partnered with Stargate as a great example of efforts to get students involved early in their careers. Is Blue Origin doing anything similar?
So we have a number of academic partnerships with universities around the country and have done a number of more targeted K-12 engagements as well near the places where we're located. So absolutely, we think that building that next generation workforce is key to what we do. Blue Origin's been doubling in size about every 18 months, so we know that we need to keep investing in that future workforce.
Can I go back to the previous question as well? I answered very quickly. I can't tell you what's in proposals, obviously, but what I can tell you is if you are not selected, you have the opportunity to ask questions of NASA. So post-selection, if you were not selected, you can debrief with NASA and they will share some of the feedback that they got through the selection process. So take advantage of that. And by the way, even if you are selected, take advantage of that. Figure out what you did right. Were there any little things that you could do better next time? NASA will share that with you in a conversation after selection.
And I'll say this is one of those things that Flight Opportunities Program does better than most places in NASA, is that it's actually constructive criticism and really actionable. So we've heard that over and over again from our investigators who maybe didn't get selected on one cycle, but got enough good feedback to get selected on the next.
I'm glad to hear that, actually.
And the awardees for Flight Opportunities Program are publicly listed, both the experiment and the PI.
Yes.
And so researchers can reach out to successful PIs and ask them what makes a good proposal.
Sure.
Erika, Blue Origin's got a lot on its plate with New Glenn and everything else going on. Recently, there seem to have been delays in test flights for New Shepard. is there a lack of emphasis on New Shepard at Blue Origin these days?
Oh, no, not at all. I think our CEO made some nice remarks this past week about how we know that this upcoming human test flight campaign is one of the most important things we'll ever do. So we're making sure we get it all right.
Okay. Well, I think that's about all the time we have. I think we've done pretty well with the questions here. There's one or two more, but they appear to be more orbital rather than suborbital. Again, back to the purpose of the panel. So thank you, Sean.
Thank you.
Thank you for the panel. We appreciate it.
Thank you, and thank our organizer, too.